When it comes to a system of equations, we're just looking at where two lines or two graphs intersect. That's it. So it's two lines. Where do they intersect? Where's the intersection point? That's the solution. One solution, move on. Unless it was one of those weird ones where it's like on top of each other, you'd have an infinite number of solutions. You would have to represent that. When it comes to inequalities, though, a system of inequalities, you've got to find the shaded region that is true for both of them. So we have two inequalities here. We're going to graph them one at a time, and then we're going to see where do they overlap. What region do they have in common? So if I start with this first guy here, who is going to be solid because of the equal to part for the inequality, think about what this equation is saying. This is saying basically that y equals x plus 2 squared minus 5. So that means we have a parabola that is shifted to the left 2 and down 5. So left 2 and down 5. And then we plot good key points from here. So that means 1 squared is 1, 2 squared is 4, 3 squared is 9, and then 16 is going to be off there. All right, so let's do this. Keep it coming right here. All right, so let's draw a nice parabola through these points, knowing where we're going to be aiming once we go off this page. All right. The other guy is less than but not equal to, so he's going to be dashed all the way. And we know that he has a slope of negative 1/3 and a y-intercept of 0, 1. Okay, so he's going to start at 0, 1, but it's going to be open, right, because it's less than but not equal to, going down 1 and over 3. So something like that. And we get more points going up and to the left. He is going to be dashed. So let's do a nice dashed line for him. All right. For this line, though, it says y is less than, so we're going to be shading below for him. If it were just that line, it would be that whole region that's underneath it. But it's not just that. We also have to incorporate what's going on with the parabola. So the parabola says y is less than, so that means we're going to be shading below the parabola. So we need to figure out, where do these guys intersect? Now I hope that you can see where they intersect, but let's see if we can get some nice things going on with the markers that we have. So if I were to shade all below this, so that would be the solution set for this guy right here. And if I do green for this one, let's see what happens. So it's going to be everything that's below or on the outside of this parabola. Well, that is not working out the way I wanted it to. Well, that's a real shame. All right, let me just go back here for a second. I was hoping that the intersection there would be kind of nice, because I think if I do this, now that you really care about it, so you can see a bit of a change there if I do that. Whatever. So I need to be, just pretend you didn't see that. I need to be both below the blue line and below the parabola. And the intersection for that is going to be all of this stuff right here. So when you're here, you are both below the parabola and below the line. This is the only place where you are below both of them. So this is your solution set. If you were to be inside here, you only satisfy the second inequality. If you're over here or here, you only satisfy the quadratic. And if you're here, well, that's not going to be true for anybody. So the solution set has to satisfy both of these inequalities. And as long as you do that, you're going to be fine.